Hello, all. Welcome to another episode of AWS Show and Tell Generative AI Edition. Good to see you all. I hope you're having a great Tuesday evening. I'm joining from New Jersey. I'm Anil Naniminti. I'm a senior solutions architect here at AWS, and joining along with me is Adam and Prakash. We'll go into some introductions here quickly. Yeah, Adam.
Adam Bloom, Senior Solutions Architect here in St. Louis, Missouri.
Prakash Srinivasan, Senior Solutions Architect from Denver, Colorado. And I will be your chat moderator. Happy to talk to you all.
Excellent. Yeah, and today we have a great topic. We're going to chat about model distillation. Again, Adam, there's a lot of chat about this billion parameter models that are coming up, and a lot of chatter there. We have specialists that are going to be joining us. We have subject matter experts, Yan Yan and Ishan, that will be joining us in a couple of minutes here, or a couple of seconds, I should say. But I mean, this is an evolving space. Adam, your take on model distillation?
Yeah, I'm super excited about this. I mean, I think this is such an important thing for agents. I mean, model distillation is a pattern that's been around for a little bit, but I think it's really going to find its place with agents as we want to scale agents across the enterprise. You're going to want to take those really expensive, higher latent models and distill that knowledge into smaller, cheaper, faster models for better scalability and user experience. I'm really excited about this.
Yeah, excellent. And we have our chat moderator Prakash, who'll be taking questions in the chat. So let us know, folks, where you're joining from, and Prakash is going to take all your questions there. Then we'll invite Yan Yan and Ishan to join us onto the stage today as we talk about model distillation. Hey, Yan Yan, and hello, Ishan. Nice to see you here.
Hi, Anil. Hi, Adam.
Hello.
This is super cool.
Yeah, so good to see you here. Again, I know, Yan Yan, you were again joining from where are you joining again?
Yeah, sure. So maybe I can do a quick intro on myself.
Yeah, let's do that. Yeah.
Oh, thanks, Daniel. So hi, everyone. This is Yan Zhang. I'm actually part of the Bedrock team, and my title is Senior Generative AI Data Scientist, and I'm based in Houston, Texas. We have a pretty great weather today outside.
Wow.
I'll go next. Hi, everyone. My name is Ishan Singh. I'm also a generative AI data scientist on Bedrock market team, and excited to be here today.
Excellent. Yeah, thank you for joining the show. And Adam and I were actually chatting about model distillation, and we have our gurus on model distillation joining us today, Yan Yan and Ishan, who are chatting on this specific topic. They are subject matter experts. So, folks, if you have questions, feel free to put them in the chat. But we do have, Adam, if you want to kick this off, let's do that.
Yeah, absolutely. So for folks watching, I think this is a really awesome special opportunity. It's not every day we get someone from the Bedrock team and a data scientist on the call with us. I'm super excited. So do you guys want to go ahead and get your presentation up and talking about model distillation and why it's important?
Yeah, definitely. Perfect. So hi, I really first want to thank everyone for having us here because we're excited about this topic, and we really hope the participants, our audience, will be able to get something from this future hour. So we want to actually talk about the model distillation specifically on Amazon Bedrock. And actually, in Amazon, we like to work backwards. We like to start with learning, from our customers, and then propose some solution for them. So in this presentation, I actually want to, work also in this similar fashion. I want to introduce first what are the key customer challenges that we hear, from our daily interactions with our customer. Then based on that, I want to emphasize why model distillation would be a good option to address those customer challenges. So first, let's talk about what are the key customer challenges. So I would say definitely, when customers are building their GenAI applications, there will be, different customer challenges. But here are the 3 key challenges that we normally hear. First, there would be about and satisfy the latency. So latency, this especially when customers are trying to build, a real-time use case, something like a chatbot, right? For RAG chatbot or agentic workflow, they want to have a better user experience for their customers. They want to, but in the meanwhile, they don't want to sacrifice anything about the accuracy, the great performance. But we know the great performance normally come from a bigger model, and that bigger model will come, with a high latency and maybe even high cost. So how to really balance this challenge become one of the key challenges that our customer normally are facing. And similarly, when we talk about the latency, when we talk about the bigger model, it also comes up with the higher cost. Still, because you are using a bigger model for your applications, you can imagine you need to use much more compute resource, and that will incur higher cost here. So this could actually be maybe easily justifiable when they are doing POCs, but when they are really trying to productionize their GenAI applications, this become a higher, challenge for them. So they come to us to say whether we can provide a better solution to help them balance the cost. And last thing will about data preparation part. So this is actually more relevant to Isha and I because we are data scientists, but we know not all customers, they may have a dedicated team, data scientist team that is working on, preparing the data set to customize their model. And even they have data scientists, we normally believe, preparing such data could be a tedious and, sometimes hassle like work. So they asked us whether we may have some better solution to do, take over all the heavy lifting from our customers and do this kind of data prep for them.
So, oh, go ahead. Sorry.
Sorry, Adam, go ahead.
Well, I actually have two questions. This is so cool, and I think this is right on here. So for latency, price of performance, how can customers think about like at what point is this? And maybe you'll get into this. What point is distillation right in terms of latency? Like, is it just like vibing, feeling the latency, or is it is there actual way to evaluate that? And then I guess the second question I have is, do you find most customers first going to wanting to think that they need to fine tune a model, but then they realize once they understand the capabilities that maybe fine tuning is really a niche, a niche use case, really?
Yeah, Adam, actually, I'm really glad that you bring this up. We plan to probably discuss a little bit later, but since
Awesome.
you already bring this up, I think we can discuss this a little bit already. So first of all, when do you need to think about fine tuning? Because after all, distillation also falls into the model customization family. So it's another way to customize the model, right? But a key question is when do you need to do the customization? Do you need to do customization from beginning? Actually, no. We would suggest customer, to start with the base model. You need to test the base model and benchmark it. Even you can go production, with the base model, but maybe at some point you will feel like, okay, the model performance doesn't really meet my, requirement. This performance could be either latency or accuracy. It could be any part of the performance. And when you think about that, you think, okay, is there any way or tools that I can leverage to push this to next level?
So you're constantly calculating, looking at the performance benchmarks and
yes,
looking at what you want to arrive at, right? It's that what's happening.
exactly. So we would say, for GenAI applications, observability and evaluation are pretty, critical components that you should always evaluate and observe your GenAI application, trying to find the bottleneck and then try to resolve those, issues that you are facing.
This is one reason why I love Bedrock because we have all the tools there, from the model customization family, like you said, to agents, to RAG, to evaluations. It's like all there. It's awesome. So I mean, I think this goes back to even though generative AI is now an application developer friendly technology, and able to apply natural language to many applications, it's still about the data, and it's still a data science challenge in that you want to constantly, to your point, evolve or monitor and evaluate the performance, of your models, your RAG, your agents, etc., continuously. It's not one and done.
Definitely. But I think, from Amazon, from AWS, our goal is to try to, take more heavy lifting from our customer and make their life easier and simpler, right?
Definitely,
So
definitely.
that's why you see on the third part when we list this, like this challenge, they don't want to do the data prep, or this become, a bottleneck for them. We want to take it over and make that easier for our customers.
And when new model providers, I mean, when model providers are making new models available, now they're making them available in different sizes, so that different, they can fit for different use cases, right? But again, that comes with a challenge. Which kind of model should you pick, and how do you get the best out of everything here, right? So can I think that's kind of the details that we're going to look into today, and we have some demos that are lined up for everyone here. Yanyan and Ishan are going to walk us through the demos and show us how you can take the best out of the bigger models and get them into the smaller models, right? I know that I put this in a very simple way, but I think there's a lot of depth to this. So I'll let Yanyan continue here.
Perfect. Thanks, Anil. Actually, you helped me make the transition because I'm going to jump to the next slide where we want to talk about what is model distillation and how does it help, to solve the challenges we were facing that we just discussed. So let's talk about the model distillation, flow here. So we actually want our customer to start with benchmarking. Benchmarking what? Benchmarking with the teacher model. So they will need to pick a use case because after all, we cannot expect the student model to perform as good as the teacher for all use cases. This isn't realistic because we're using a much smaller model, right? But we want them to pick a use case, and then benchmark with that teacher model. Only if they see the teacher model is meeting their expectation for accuracy, then it probably is the time to think about distillation. Because if you are still facing the gap for teacher model's accuracy, maybe you should think about fine-tuning in this case to push the accuracy to next level first.
Yeah, so Yanyan, I want to pause for a second, right? Because I know our viewers may get what the teacher model and student model is, or maybe not. So if you can spend some time to just quickly get everyone up to speed on what is a teacher model, what is a student model, and how they fit into this whole
Sure.
in
Yes,
this thing here.
definitely. So let's talk about distillation first. So distillation is the knowledge transfer process actually. So we have a much bigger and more capable model. Here we will call that as a teacher model. And then that teacher model will transfer the knowledge to a specific use case or specific, types of use case. And to transfer that knowledge to a much smaller but faster and cost-efficient model. Here, we will call that model as a student model. And the distillation will be actually covering this entire process of knowledge transfer. So you can see the key here is to have a student and a teacher model. And when we talk about distillation, the beginning, like I just shared, the entry point is you pick up a use case. And then based on your use case, you benchmark with the teacher model that you select. If you believe the teacher model is meeting your accuracy requirement, then like we're showing here, you first use your prompt to invoke the teacher model and to generate server response, right? Like that is corresponding to your prompt. And then together with your prompt and response pair, we will customize a student model. And when we say customization here, we will update the student model weights, to let this student model perform better on your picked use case. And after the model weight is updated, you can expect you will have a distilled student model. And in future, when you have new prompts coming in, this new prompt should be still relevant to this use case that you originally designed. And when new prompts coming in, you just directly invoke with the student model. You can expect, because the student model is a much smaller model, you actually have lower latency as well as lower cost. But because of this customization, phase, actually this student model will perform much better than the base student model. So that's why this model distillation is a process to help you, to improve the latency and the cost, in the meanwhile maintain a great accuracy. And because we're doing that on Amazon Bedrock, it inherits most of the benefits that Bedrock, that can do. So we make it easy to use, it is secure and also private.
I think we have a question here from Zero Sleep. Customers doing both RAG and distillation together to ensure app customer data is up to date and ready for inference? It's a great question.
So both rag and distillation together. So this is a great question, actually. I want to break down, especially for rag use case. I would like to break it down a little bit. For rag use case, actually, you have two major components, right? You have the retrieval and the generation. So think about the retrieval part. Retrieval is you have an embedding model and you store all the embeddings into a database. And once you have a new user query come in, right, you retrieve the relative informations. And the distillation actually has nothing to do with the retrieval piece because the retrieval is highly relevant to the way you find that you do the like the semantics, maybe the search, or you have a lot of things to do with the embedding model. But distillation will primarily focusing on the generation piece of this use case. So once you have retrieved certain context in your prompt together with your user query, the question, the distillation will be able to generate a much faster response back. But in the meanwhile, because it is highly customized, it will should still give you a much better response. And later on, when Yishan is doing the demo, we actually want to focusing on a RAG use case. So you will see in the prompt you prepare, you should provide both the context and the question so that the model will be able to pick it up and learn how to generate a better response.
That's awesome. That's such a great answer. I maybe have one question as from a data science standpoint. As model distillation is, I'm so excited to see the demo, but from a bigger, smaller model family, like I think about Llama 4, for example, or Claude, why don't these model providers, just simply distill the larger model into their smaller model and just provide that in the first place?
Yeah, because Adam, think about the starting point of distillation, right? You need to pick up a use case. And the model provider cannot basically cover all the use cases, right? And even they do, probably it doesn't really work either great for your specific industry or the problem you want to tackle with. So it's always great to customize the model with your use case and your data. So that way you actually leverage the best.
That makes sense. Okay, thank you. Yeah.
Sure. So I have one more slide to talk about before I hand it over to Ishan. So I want to actually talk about the key benefits that we are offering for our, Bedrock distillations. The first, I think we have already covered a lot, right? The efficiency and cost optimization. It is great actually for use cases like RAG or agent. But also, we actually, when we build this service, we have a principle in mind, is ease of use. Because our customer challenge was one of them was because they don't want to do all the heavy liftings, right? So we actually automate the fine-tuning process. The customer, they don't have to even specify hyperparameters like epoch or learning rate. We will actually do all those work. We will hand it over. Customer just have to tell us where their data locates, help us identify the use case, and provide us the training data. And then basically provide us the use case prompts. And then we will take it over from there and help them do the deployment.
So Yanyan, we have a question in the chat that's relevant here. I can bring this up. So how should, this is Atul asking a question, how should users prepare to train a new model using distillation process if they have different modalities like text and image and audio? So do they do anything different? What process do they have to take?
Sure.
That's such a great question.
Yeah.
Yes, definitely. So currently on Bedrock, we support text-only distillation. That is the current, but we always listen to our customer. So if you have a certain use case that is multimodality, basically, please let us know so we can work together, to basically help let our service to support your needs and your use case. Sure. So I think. Sorry, Anil. Did I agree?
Excellent. I said, there is so basically that right now we support text, but there is, we are always listening to our users, customers, and we are open to feedback. So let us know if you're interested in this. Reach out to your solutions architects and keep us posted, right? So we are constantly listening. Our product teams are looking for feedback so that they can improve the product, right? And yeah.
Exactly. Thanks, Anil. So two more things is actually here is actually a big thing. We actually apply some science innovation behind. So we not only do basically we not only do the distillation process, but if there are certain use cases that we will actually apply data synthesis techniques for our customer. So what it does is we will augment the customer training data, if we believe, there's still room to improve, we will augment their data. And that way, they can actually make the distilled student model performance even better. So we will help our customer to apply this science innovation, behind the scene. So they don't have to worry about this part. We will do that automatically for them. And lastly, it's about exclusive access. So currently, customer will only be able to distill Anthropic or like Amazon Nova models available on Amazon Bedrock. So that's pretty much for my part. And I would like to hand it over to Ishan now, maybe do a demo.
Okay.
Oh, Anil, you are on mute actually.
Yeah, so I have a question, Yan Yan. Thanks for that. So when we talk about model distillation, are we allowed to do model distillation only within the same family? Like, you mentioned that we have Anthropic and Nova models. So, what is the current state of, how we can support right now?
Yes, that is correct. Currently, Anil, we have to stay within the same model family. So you can only do like cross-provider distillation isn't supported as for now. But like I shared, we always listen to our customer. So in case you have a certain need, please let your account team know.
Is it
Sure.
theoretic? Is it? Oh, sorry. Go ahead. No.
No, I was just saying, echoing that. Yeah.
So is it theoretically possible to do cross model, architectures or model families from like say Anthropic to Llama or vice versa? Is that technically possible?
I mean, there are actually multiple reasons to actually drive this decision. So it's not only technical. I would say there are multiple reasons that actually drive to this decision. So as for now, like we just don't support cross-provider distillation.
It makes sense. I was just curious if it was like theoretically possible.
Mhm.
Yeah. I would imagine the weights would get all weird.
I mean, ultimately, you're training the models, right? So that's what's happening, right? So it must be something that's possible. But yeah, let's go to Ishan now. And Ishan, what are you going to show us? Is it like demos? Is it going to be slides? What is it?
Yeah, so I have a few things. I will walk you through a few things like how to set up a distillation job, what are some of the nuances there, and then later on we will also do a live demo where you will see how a distilled model performs. So before we get into distillation, how to set that up, I want to cover what the process of distillation looks like. There are really three main steps that are there in like how you distill a model. The very first step is towards this right hand side upper corner, where you have your data scientists, your machine learning engineers evaluate a teacher model and evaluate a student model. So usually these evaluations are from the point of view of, so for teacher model you would look at quality piece, that if the responses meet the quality standard that you have. And quality here is a buffer term that I'm using, so you may have like different definitions of quality based on your use case. For a student model, you would then be interested in, hey, how fast this model is, whether the cost fits my budget and all those things. So that's piece number one of distilling a model. Then on the second side, you have to prepare your data set. With Amazon Bedrock model distillation, there are two ways to do so, and we will cover those later on. But I want to cover some nuances here about preparation of data set. The very first thing I want to call out here is garbage in is equal to garbage out. So this principle has been around for a very long time, and it is still true in case of your model distillation. So when you prepare your data set, you have to spend time on that piece, because you want to make sure that your training data set is really representative of what you define to be your real world use case. If your training data set, for an example, let's say if you have a agentic use case, and your agent may want to use certain like RAG vector stores, but also certain tools where it can make an API call. But then in your training data set, you don't have, let's say, the data for making that tool call. So it won't be a real representative. I know this is like a very basic example, but it just conveys the point. So you want to make sure that it is, valid, it has all the right pieces there in the data set. And then comes the third piece where you train a model and then deploy it. So Amazon Bedrock makes it really easy, as Yanyan has already mentioned, that it makes it super, super, super easy to, start a job and then finally deploy a model. And you will see those in just a few minutes. So I want to just dive a bit deeper into the evaluation piece, because really that's how you would get started with model distillation. And as Yanyan mentioned, observability and evaluation are really the two core pillars that would help you go into production with any generative AI application. So what I'm showing you on this slide is a sort of like a moving scale between three components: quality, cost, and speed. So as you decide the model that you want to use, you will almost always have to wave off something in order to get other. So if you have a high quality, usually those models are going to be more expensive and slower compared to, let's say, another model that is much faster to like complete the request. Usually they would cost a little less and the quality would also be a little less. So the second case is a very good fit for your student model, and the first case where the high quality is there is going to be a very good fit for your teacher model. And as we have already discussed, uh, right now with Bedrock model distillation, you can distill a model within the same model family. Okay, so let's get into like how we would set up a distillation job. So there are certain nuances that I want to cover real quick before you can start. So this, what we are seeing here is your Amazon Bedrock console page on AWS once you have logged in. In order for you to get started, the very first thing that you need to do is to enable model access. So this really means that, hey, now you are enabling access to certain models. And as you see, there are like a lot of models that are available in the base model category. And then there is like marketplace as well. So you have hundreds of models that you could use. Now, having said that, let's look into the customization piece of model distillation. So I've already like opened these into different tabs for like quickly navigating through them, but yeah, this is the option that you would select. Now going into the console, you would find your model distillation job right here. And now here, what I want to emphasize on the very first thing is really this is a very small form of sort that you would fill to start a model distillation job. But all of the thing that we are covering right now is also available through an API. So I'm just choosing to show you the console, but I will also show you how that looks into in code in just a couple of minutes. Very first thing, and it's an important thing that I want to highlight here. So the name that you choose here, in this case it says distilled model name. This is the exact model name that you would use once your model is ready, it's trained, and you want to use it for inference. So just use this nicely as like how you uh, so let's say in this case I call it my name model distillation demo model.
Mhm.
And then you can associate different tags. So these would help you allocate cost tagging.
I have a question on the encryption. What's the model encryption about there?
Um, yeah, so this model encryption, so you could optionally choose your KMS key so that the interactions in your model is encrypted. So this just adds additional layer of safety for you.
That's awesome.
Yeah, so you can specify your own custom key here. Then this is your model job. So you may like want to experiment with different models. So let's say you sign up for different jobs. So this is just like your job name. And then again, you can associate tags with it. So here comes the piece where you have to select different teacher models. And the expectation in this case is that you have already evaluated your teacher model. And evaluation here is on quality. point of view.
And would
So
you
right,
evaluate that using model evaluation within Bedrock, perhaps, or just testing
yeah,
it out on your own data in the
yeah,
playground?
absolutely. So there are multiple ways to do so. Like I know typically, like when we start working with model, we start with like generally, like vibe checking with model, whether or not it fits the standard and the tone that we want and the type of responses we are getting. But once you have done that, then you start into a more formal evaluation. And yes, absolutely, Bedrock model as judge evaluation can come in very handy in order to evaluate these models. It supports evaluating literally all models available on Amazon Bedrock, including any customized model, which includes distilled model.
That's awesome.
Excellent.
Thank you.
Yeah. So since I'm in Northern Virginia region, in this we have the Nova models. So you could choose between Nova Premier or Nova Pro as your teacher model. So let's say in this case I pick up Nova Pro, but let's say if you were in a different region, there you would have different models available. So models from Anthropic and also models from Meta are available for your selection. Then, since we allow or we currently have the distillation support for within the same model family, so you could choose between Nova Light and Nova Micro depending on like your initial evaluation of these models on the same use case using which you evaluated your teacher model. So let's say in this case I pick up Nova Light model. Now
And
here.
a quick question, Ishan, like as we yeah, over there, right? So the teacher model. So let's say that we are in that you picked one of the existing models. Do you also, right now we have the ability to pick an existing model, but not pre-trained models, right? So the models that are already tuned, or there is something that's already happening. Right now this is a base model that you're picking, and you're using that to run your
Yes, that's
distillation.
exactly right. So you would choose a base model in this case. So yes, that's absolutely right.
And I have another question, sorry, really quick. So from a data science perspective, is what's happening behind the scenes with model distillation from the teacher model to the student model? Is it like basically doing like gradient descent, like further like, you know, what's the term there? Like with the loss function, reducing that? Is that what's happening here? Is it just like increasing the accuracy that much more to the nth degree?
So let's look at some of those pieces in a bit like
Sure, yeah.
broken down pieces. So typically when you train a model, there is certainly some loss functions, certain updates that are made over a process. So that is absolutely been done here. With Bedrock model distillation, what happens is once you have your initial data set available, then we apply as I have it right here in the next section, synthetic data generation. So we apply certain proprietary techniques there to sort of further, like extract most out of that data set so that we can make the model much more robust for your use case. So then it's a combination of all these steps, ultimately resulting into updating the weights of the model, which basically means it's really a new model that's customized and specific to your use case.
To reduce the loss for your use case. That's awesome.
And
Okay.
we have these jobs that you showed us, right? So does it mean that you're repeating this process, and why would you repeat it like multiple times, right? If you're already training a model, does it mean that you have new data and then you're repeating this job, or are there any other reasons?
So there could be a number of reasons. One could be that your data has changed, your use case has evolved. You may now want to test a new model altogether. So all those pieces are there. Maybe you are now adding support for something else. Maybe your use case now has like additional features that you want to incorporate in your student model. So those could be like some of the reasons why you would want to train again. And also, like, so these are like the good parts, like when you would train a model again. But there are other things too. Like, let's say when you trained in the initial phase, let's say your very first job, you did not have all the data that you wanted to use. Maybe your data quality wasn't high enough such that now when you are evaluating the model, you're not seeing those performances. So now you improved the data set. You sat with your, let's say, subject matter expert, and improved your data set quality. So all those pieces also come into this.
Sure.
Awesome.
Yeah. The next piece here is your synthetic data generation. And the very first thing to look at here is the response length that you want your distilled model or the smaller model to be trained on. So really, this doesn't change model's speed or quality per se, but it sort of gives your model the ability to learn that, hey, this is the max length that I am supposed to generate a response. So same thing happens for your teacher model. So when we generate those synthetic data set, we use the same max length for the response generation.
Does
So
that impact cost to distillation? Sorry, no.
So yes, in ways, yes, because the cost for your data set generation is based on per token generation and like the number of token consumed, so both input and output, and this directly influences the output.
and I'm also gonna ask, like, do you select uh, lower length or higher length, or is it like again the balance that we're talking about, right? As to what is best that fits the use case.
Yeah, so it depends on a couple of things. First, it depends on your use case. If your use case requires long responses or it requires short responses, that's part one. Part two is based on your study about user experience. So if you know your users prefer, let's say, summarized view of the response, or maybe they preferred longer responses, and your use case also supports it. So it's a combination of both of these. So literally, you are experimenting with like your user base, or based on your previous user studies, as to like what should work best for your use case. So it's really dependent on those facts.
Yeah, whenever there is a slider there, it solves the question, where do we land it, right? So on the lower side or the higher side, and yeah, it all depends on the use case and what your student model should really be
Exactly.
doing in the future.
Yeah, and there is also usually as we spoke about, the couple of main use cases where customer want to distill a model is either for a cost or for speed. So selecting, let's say if you are training with approximately, let's say, 600 max output length, your perception of latency improves compared to when the same model has to generate 1600 tokens. I'm not saying that the model is generating tokens faster, but the perception of request completion has improved because, hey, it's doing less work. So that also is a factor of this, and that's why I said that it also depends on your user studies how that works out in your use.
That's a good point. It's kind of about perception is important too.
Yeah, I was going to ask, like, why perception, right? Because obviously, like, the more the length the response, there is a lot of STDIO. In this case, it's not like standard input output, but there's definitely emitting tokens out
Mhm.
versus less number of tokens, right? Is it
Yeah.
perception, or is it actually happening behind the scenes? Like,
So it's going to be similar speed in both cases, be it, let's say, you train it at 1600 or you train it at 600. The speed is not going to change. The model is still, using the same infrastructure or, architecture, for an example. So that's not changing. What's changing in this case is your model is just completing the request faster because the request is smaller.
mm-hmm.
So 600 tokens is smaller than 1600. So the time the model would take in general to complete 600 tokens is less than what it would take for 1600 tokens. So the perception of that, hey, my request got completed, has improved.
Okay.
Yeah. But the actual times don't change. The actual speed is not changing. Okay. Now, moving on, there are two ways you could provide your input data set for a model distillation job. The first one is that, hey, you have your prompt and your response pair, and you could upload those in the required format that's needed, and we will look into that format in just a second. So you can do so in a JSON L file and put that in an S3 bucket. But then there is another method using invocation logs. So let's look at what invocation logs mean here. Invocation logs are, let's say you have already been experimenting with these teacher models and you are liking the responses, but you are now also saving those in, let's say, your S3 bucket or maybe a CloudWatch log group. So you could use those as your input data. And in order to be able to use in model invocation logs, what you need to do is first you need to enable those. So there is a settings option within Amazon Bedrock where you can go and enable the model invocation logging. So you could select S3, you could select CloudWatch, or you could select both. And then based on your input, you then finally provide certain tags or key or value pair in this case. Let's say your key is maybe, do you want to use it for model distillation, so you say model distillation and the value is true. So you just then specify it here, and then Amazon Bedrock model distillation would pick exactly those records from the S3 bucket, or yeah. And
And I believe
since
that is a very powerful feature, right? Because you're not providing any input data like outside of the context, but this is live data that your users are hitting
yeah,
the actual model, the teacher model, that can be used to train the student model, right? So this is a very powerful feature.
yeah, exactly. And it also saves on cost, right? Because you don't have to regenerate some of those responses. So it's, like benefits on both the sides.
That's also a good point because it goes to garbage in, garbage out. If the model invocation logs are just a bunch of users playing around, being silly, then you're not going to get a good result.
So yes, that can also be the case. So again, you can define those filters in order to, subset those use cases. So yeah. And let's say if you know the prompts are right, but maybe the response are not right. In the cases of your previous invocation logs, what you could also do is you could just have your model distillation job only read the prompts from the existing invocation and generate a response. Or if you really feel sure about that, hey, the responses are also good quality, high quality, then you can just use those, and you don't have to generate those responses from the teacher model. So it really saves cost as well there.
That's really cool.
Yeah. And then literally the last step is to provide an S3 bucket where you would want your output metrics, your reports, your insights, samples of the training data set in an S3 bucket, so that you can then further dive deeper. You could optionally set up all of this inside a VPC, as we also saw that there is a support for KMS encryption, so you could do that too. And yeah, that's pretty much it. So it's very much managed, and as Yanyan has mentioned earlier, so we already manage all the epochs and learning rates for you. So those are again fully managed. So the real value that the model distillation is bringing here is not just about setting the job or having a managed creation of the job, but it really saves a lot of time for you to maintaining all those hardwares or writing those complex training scripts. So it does all that for you in just as we see this much of the
Like just without using code, we are just seeing how we can train based on actual invocations from a teacher model to a student model, right? So I mean, this is fabulous. We also have a question in the chat from Jagdeep, and this question is like this. We'll probably get to this in a little bit, but what are the proven best practices to adopt distillation process? I don't know if you're going to share some knowledge on this towards the end of the session here, but yeah.
Yeah, so I can quickly cover those couple of points there. One, I would say the number one proven step is really your experimentation and evaluation. The higher quality evaluation you perform in the initial phase, it directly speeds up the process of going to production and having a higher quality distillation. The second piece is the amount of time you spend on preparing high quality data set that is used for model training, and thus also in generation of the synthetic data set. So these two are like really your core elements, I would say, in order to like have this very high quality model distillation. Okay, so once like you create this distillation job, it since it is like large models and it has like multiple steps, it may take a few days in order to get the model ready. Once it is ready, currently Amazon Bedrock supports provision throughput for custom models. So you use those. Let's say you pick up an hourly provision throughput, and then you can test with your distilled model. And then again, as a last step, you still have to evaluate the distilled model before you put it out in your application. I know we are coming to an end here, so I'll quickly walk you through what the code process looks like to set up these jobs. And I'll not take a lot of time because we have covered literally all these things. All the code samples are available on our GitHub. So I'm scrolling down a little faster because yeah, first I want to show you like all these are like your standard imports that you would have when you are setting up really your model distillation job. This is a core element I want to cover. So this is the format in which you should have your data set. You have your system prompt, you have your prompt and or context. And I will show you an example of this because we want to show an example on a RAG use case. And then lastly, your ground truth that you could also provide in your prompt.
Yeah, and for the viewers that are just catching up to this, Prakash is in the chat. He's going to put a link to the GitHub repo, whatever is being shared by Ishan here. So yeah, you can probably take a look at that in a little bit.
Yeah. And then like this function really is just preparing the data. Let's say you have it in a text format. So now here we are just enabling and preparing the data set to have like a JSON-L format. And then lastly, we add your system prompts. We have your input. In this case, as you see, it's a JSON-L. So that's my input, and output is also JSON-L. You really are just merging those things like your system prompts and your context and everything. Over here, if you see, then I'm just defining my job name, and all of these are you probably are now able to map it with what we saw on the console. So you have a job name, you have a model name, you have region and everything. You have your S3 buckets. And finally, this is what the API call looks like to start your model distillation job. Really easy, small. You define that your customization type is distillation. You provide what your model name is. You provide what your student models are, what your teacher model is, what your max length is, and where your data is. And really, that is it. The job then runs. Once it, you can also monitor different status of the job as it's running between like data set preparation, validation, and all those other things until it gets completed. And then finally, you deploy it using a provision throughput. So this is where you would have your distilled model deployed. Then you can finally test it. Now, I know that there was a question about using like RAG and also distilled model. So this is like firstly, this is what my general JSON-L file looks like with different prompts. So one line here is like one full prompt with your system prompt, with your question, prompt, context, and everything, and finally a response as well. So this is in your training data. Now I have opened one example up so that you can clearly see that my very first thing is a prompt. I just tell that, hey, you are a financial assistant who is in charge to answer questions of 4K filings for a company based on context. And since I mentioned context, as you see, my next step here is context. And then I have my documents here. It's a very long list of documents that I have provided in this case. So imagine this is the piece that comes from your RAG vector store. Then this is the question that you want to get answer for, and then here is your ground truth. So this type of data set is something that you would use for your when you are providing the data in a Amazon S3 bucket. If let's say you are using invocation logging, then in that case you would have a very similar setup, but except for that, let me scroll down real quick. Yeah, so in this case, your training configuration would be the location of where your invocation logs are and what are those metadata filters that we should use to subset from the long list of your invocation logs.
So you can filter the data as well as,
Yeah.
just don't need to take everything, but yeah.
Yes, exactly. Yeah, that's the point for the invocation logging. Yeah, and then everything else remains the same. This is the same API call, literally, as you can see, same identifiers and everything. And finally, once you have that ready, and it is also okay if the job runs up to 7 days, depending on how much data you have, what type of model you are using. All those things are affects basically the time it takes to train the model. And then finally, as you see, deployment is super similar in both the methods, be it whether you use an S3 bucket type data or you use invocation history. Okay, so with that, let's have Yanyan show you how a distilled model looks like and what we can do with that.
Thanks, Ishan. So I would like to take it back and walk you through, a little bit after you have submitted your distillation job and your distillation job finally completes what your, basically the journey would be. So we are currently at my console right now. I have distilled a model. It's a Llama 4.5B to a 3B. It's a RAG, basically RAG use case distillation. You can see everything is here. I have my training job. And here, this is one enhancement that we have done since we GA the distillation feature, which was actually the end of April. So we basically provide better job status updates. Our customer will be able to know whether your current job is in the validation phase, where we are preparing the data, or you are in the training phase. And you will be able to track all the job status until it all shows complete. And once it's all complete, you will have a model ready in your console. And what you can also do is coming to this output matrix folder. This is the place S3 location you specify when you submit the distillation job. If we come to here, you can see there are some subfolders. There are the input data report. If you click this one, you can see there's a manifest file. I can show you real quick, like my example here. I trained actually with a very small data set. I only have 150 records. So you can see it says, okay, we processed all 150 records and all these records are being accepted. There's no partially accept or rejected prompts. So basically, you will be able to know how many records that actually have been used. And in case there will be partially or rejected prompt, we will let you know the reason for that rejection or the partially accept. And then in another folder, like if we go back here, you will also be able to see either the training artifacts or the validation artifacts, because we will actually do some auto split for you for the validation purpose. And for the training training artifacts, you will be able to know this is the stepwise matrix that you will be able to find the training logs here. But this is another add-on that we have added during the GA. So basically, you will be able to get a subset of the training data. So of the training data for the distillation process. If I can also open this one. So you can see here, we provide up to 50 records for Llama and Nova model and 25 records for Anthropic models. These are the prompts actually from what Ishan was showing. But here we provide, you can see we provide the completion field from you can see here, it has the role assistant. And this is actually from the teacher model. So basically, we're providing a subset of the training data. So you will be able to know what kind of data your distilled student model were trained with. And lastly, I want to play already, very fancy and interesting part. Here, I have a compare mode enabled. Left-hand side is my distilled student model, and right-hand side was my original teacher model. So let's run a simple prompt. between these two models. So here, I have still a RAG use case. I have my system prompt, I have my context, and in the end, I have a question. Let's see.
Mhm.
So the distilled model will be able to get back to me, only about using 1/3 of the time of the teacher. But if we look at the response, the result basically, you will be able to know actually it's very similar as the teacher. So basically, it provides a similar or income, basically on par accuracy as the teacher. But in the meanwhile, look at the latency that you have, the time you have saved. You are basically using only 1/3 of the time by invoking the distilled student model.
Awesome.
Yeah, this
So
is
cool.
great, right? I mean, obviously, like, why wouldn't you want to now do distillation if this is available to you? I mean, you could get the best out of the larger models. And also, as we recap, Yan Yan, just one more. I know that you spoke about distill 4053B. Can you talk about what that is, 4053B RAG model, and what's on the right side?
Yes, the right-hand side is the teacher model. It's the original base 405B from Llama. And the left-hand side was my distilled student model. It's a Llama 3B model. So you can see the model is much smaller. That's why we're having this latency improvement.
Excellent. And we also have some questions in the chat that came up. This is one of them. Does this avoid the need for fine tuning? This is from Akbar.
Yeah, actually, because we actually take this, we basically do the fine tuning behind the scene for customer. So I wouldn't say this avoid fine tuning, but if we look back a little bit, what are the good, differentiator between fine tuning and distillation? So for distillation, we would say normally if, the customer are already satisfied with the accuracy with the teacher, but they want to have a better, latency or better cost, they will probably consider using distillation. Versus for fine tuning, this normally you should consider fine tuning when your model doesn't really meet your accuracy requirement. You really want to push the model to next level to perform even better. That's when you should start considering the fine tuning.
Excellent. Now, as we're getting close to the end of the hour, any takeaways for our viewers now as we get close to the end of the session?
I think I just want to share like a little bit. It's on Amazon we're pretty customer obsessed, and we always listen to our customer. You can see we even build this service because we hear from customer challenges. So we really appreciate all the feedback that or the challenges you are facing. Please do let us know so we can further improve our offerings to solve your challenges.
There you go, Yanyan. So we have feedback coming in right here. So yeah, great topic today, great session. We went into a lot of details. Adam, any closing comments?
Yeah, this was really educational. I think this is awesome. It gets me really excited about distillation. So I guess the last question I have really quick here is, do you think more customers should be doing distillation, especially when they think about going into a agentic workflow?
Yeah, so definitely, Adam. Actually, I think we just shared a blog post as well that was published by at the end of April, that we were focusing also on agentic, function calling use cases. So distillation is definitely one of the way to help your agent model perform good, but in the meanwhile perform faster and be cost efficient. So we definitely encourage our customer to try it out, but still we encourage them to benchmark. It still ties back to observability and evaluation here. So start with benchmarking, and once you are seeing satisfied result, let's try distillation.
Excellent.
Awesome.
Thank you. Yeah, and thanks for tuning in for another episode of Show and Tell. Thanks Ishan and Yan Yan for joining us, and Prakash, you kept this chat so lively. That was great. All right, we'll catch up next time, and Adam and I, next time, next
Thank you,
week.
everybody.
Bye.
Thank
Thanks,
you.
everyone.